Let's summarize what we have studied so far about energy and work. We know that a force acting on an object in the direction of motion does work on that object. If the force is in the same direction, then the work done is positive, but if the force is in the opposite direction, the work done is negative. The kinetic energy is the energy an object has due to being in motion, due to having speed, which is defined as 1/2 mv squared. The potential energy is the energy related to the relative positions of the elements of the physical system. For example, the position of an object with respect to the surface of the Earth, or the elongation of a spring, or the distance between two electrons. To the sum of the kinetic plus potential energy, we call it mechanical energy. This is a quantity that is conserved. From the definition of work, we have that W is equals to F times dx. We know that this is also equal to the change in kinetic energy, but it is also equal to the negative change in the potential energy. If we substitute the work by the negative change in the potential energy, we can write that the negative delta U is equal to F times delta X. We can solve for the force and get that the force is equal to negative delta U divided by delta X. In the limit of small changes, we have that the force is equal to the negative derivative of the potential energy with respect to position. We can make a graph to plot the dependence of the potential energy with respect to the position. For example, consider a stone of mass m at rest at a certain height h. It will have a potential energy mgh. If we drop the stone, it will lose potential energy. The potential energy versus height is a straight line. The closer to the ground, the smaller the potential energy. But if the mechanical energy has to be conserved, then the stone will always have its initial energy, call it E naught, which in this plot is indicated by this highest value. As the stone falls, it decreases the potential energy, but the difference between its current potential energy and its maximum energy is then the kinetic energy that the stone gains as it falls. This type of plots are very useful in obtaining information about the dynamics of the physical system from an energy point of view.
Let's consider this result we just found, that the force is equal to the negative derivative of the potential energy with respect to position. In the case of the gravitational potential energy, mgy, if we derive that with respect to the height y, then we get that that is mg. If we change the sign, then we find that the force is equal to negative mg, which we already knew.